Hi, my name is Jason Harlow. Welcome to my V Office Hour. I'd like to go over Physics 131H1S Winter 2011, Term Test 1, Version 1, Question 2. This question is based on Knight Chapter 2, Kinematics in One Dimension. So first, let's carefully read the question. A jogger runs at a constant speed of v sub j equals 10 kilometers per hour to the right. And there's a diagram there. A walker walks at a constant speed of v sub w equals 5 kilometers per hour to the left, towards the jogger, also shown in the diagram. When the jogger and the runner are a distance d equals 3 kilometers away from each other, a bird flying at a constant speed v sub b equals 30 kilometers per hour to the right passes the jogger. The bird is shown in the diagram as well. When the bird reaches the walker, it turns around and flies back to the jogger at the same speed. When it reaches the jogger, it turns around again and flies to the walker. It continues flying back and forth between the jogger and the walker. When the jogger and walker meet each other, how far in kilometers has the bird flown? And all the answers are given to one significant digit, 1, 2, 3, 6, or 9 hours. So the tempting way to do this problem is to first find the time that it takes for the bird to fly from the jogger to the walker. I suppose you could find the relative velocity of the bird relative to the walker, which would be about 35 kilometers per hour. Compute that time, and then the distance between the walker and the jogger will have reduced by some amount in that time, so compute the new distance, and then find when the bird turns around and goes back, the relative velocity of the bird to the jogger, which will, it looks like it'll be 40 kilometers per hour. There's a new distance, a new time, and find that distance, or find that new time, add it to the first one, then allow it to go back and forth, a certain number of times until they finally... That's not the way I'm going to do it. Distance traveled is equal to the speed times the time elapsed. We know the speed, which is constant, of this bird. So the question is, do we know how much time it was flying? Yes. How much time it's flying is how much time it takes for the runner to meet with the jogger. So all we need is the speed of the bird, which we have, it's 30, and the amount of time that it takes for the walker to meet the jogger. And you multiply those two, and that's the answer. Simple as that. So let's take a look at my solution. Okay, so basic idea here. Let's write down some of the things we know. We'll set positive to the right, So the v of the jogger is plus 10 kilometers per hour. And the v of the walker is equal to negative 5. The screen here, negative 5 kilometers per hour. And so the relative speed, velocity, v of, let's say, the jogger relative to the walker is equal to the plus 10 kilometers per hour minus this negative 5. And so 10 minus negative 5 is plus 15. So v of the jogger relative to the walker is plus 15 kilometers per hour. And you're asked for the time until they meet. Time until they meet. Actually, you're asked for how far the bird flew in that time, but the time until they meet will be, we know that v of the jogger relative to the walker is equal to the distance between them divided by the time for meeting, because they're originally at a distance d, and that's true in either frame, the relative to the walker or relative to the jogger, and this is the time that they meet. So this is their relative speed. So time meet, if you solve that for meeting time, is equal to d divided by their relative speed. So it's equal to 3 kilometers divided by 15. And this will be in hours. If you take kilometers per hour, or sorry, kilometers divided by kilometers per hour. Okay, and then you have the bird, so that's some number of hours. Meanwhile, okay, the bird flies at 30 kilometers per hour for that number of hours for 3/15 of an hour. So the distance traveled by the bird, it doesn't matter that it's going back and forth, because I guess we just assume that it instantly changes its direction every time it meets one or the other. So it's going back and forth, but at all times it's traveling at this speed of 30 kilometers per hour. So the distance is equal to the v of the bird times the time for meeting of these two. So it's just equal to 30 kilometers per hour times 3/15 hours, and so equal to 3 times 30 divided by 15, and I get 6 hours. And in my selection there, it's answer B. Let's quickly assess the answer. The bird flew 6 kilometers, even though originally the distance between the jogger and the walker was 3 kilometers. So by going back and forth many, many times, as the jogger and walker close in on each other, the bird ends up going twice as far as the original distance, which makes some sense. Sounds pretty good. My name is Jason Harlow, and I approve this message.